All right, so here we have the logarithmic function's been transformed a little bit. We have 2 times log base 2 of x minus 3 now. So my approach now is going to be, let's find the domain. That'll help us with where the asymptote is located. Okay? So I take the x minus 3, make it greater than 0. X is greater than 3, which means the asymptote would be at x equals 3. Go ahead and draw that in. Okay, now evaluating logarithms by hand is sometimes pretty tricky. We want to try to evaluate by hand to where we get nice results, okay? And this is where the base of the logarithm comes into play. So I need you to ask yourself this question. Since the base here is 2, what values of x can be plugged into this function to make the argument a perfect power of 2? Now again, by argument, this is the argument of the logarithm. I want that to turn into a perfect power of 2. So I have a bunch of them listed here. 1/4, 1/2, 1, 2, 4, 8. Those are all perfect powers of 2, right? Let's start with the 1. Okay? 1 is not going to be my input. What value of x makes this argument turn into a 1? X would equal 4, right? So that's going to be a good choice for an x value. Now let's show a little bit of work on this. So if I plug that in, it would give me 2 times log base 2 of 1, right? Well, what is log base 2 of 1? This is where you got to understand your logarithms. Log base 2 of 1 means 2 to what power is 1? 0. So I can substitute that in and make this 2 times 0, or 0. Ultimately, that gives me a point at 4, 0. Okay? So I use that perfect power of 2. Let's move to a 2. What does x need to be to make this argument turn out to be a 2? 5, right? So that will lead me to 2 times log base 2 of 2. What's log base 2 of 2? 2 to what power is 2? 1. So this would become 2 times 1, or 2. Gives me the point 5, 2 then. Okay, now the next perfect power of 2 is 4. What does x need to be so that when I subtract it by 3, I get a 4? 7. So that's going to take me to 2 times log base 2 of 4. Well, what's log base 2 of 4? 2 to what power is 4? 2. And then 2 times 2 gives me 4, to where I now have the point 7, 4. Okay. All right, now if you want to see more accurately the behavior near the asymptote, you got to go in the other direction where these fractions are. So a perfect power of 2 is also 1/2. What value of x when subtracted by 3 gives you 1/2, or 0.5? 3.5, right? So that would be a reasonable value to choose. That's going to give you 2 times log base 2 of 0.5, or 1/2. Maybe you need to see it. What's log base 2 of 1/2? 2 to what power is 1/2? -1. So this is 2 times -1 or -2. So we have a point at 3.5, -2. So yeah, that's getting pretty close to the asymptote. All right, 4 points is plenty. Along with the asymptote, we can draw the curve very accurately. Okay. All right, now I want you to notice this graph here, it's just the original parent function y equals log base 2 of x. It's been shifted 3 units right and vertically stretched by a factor of 2. Okay, so if we go back and we look at that red function there, that was y equals log base 2 of x. All we've done is shifted it 3 right, asymptote moved then along with it, and then we vertically stretched it to where, notice all of these points are now 2 vertical units apart rather than 1. So your transformation rules could be applied here as well. Okay. All right, let's do one more, example 4. Okay, domain here, 2x minus 1 has to be greater than 0. X would be greater than 1/2. That means the asymptote is at x equals 1/2. Go ahead and draw that in. All right, now the base of this logarithm is changed. It's now a 3. So I need to be focusing on perfect powers of 3. What numbers can be plugged in for x that will make that argument of 2x minus 1 turn into a perfect power of 3? So let's start with the perfect power 1 here. What does x need to be so that 2x minus 1 would produce a 1? 1. So this will give me 1 plus log base 3 of 1, or 1 plus 0. Log base 3 of 1 is 0. 1 plus 1, or 1 plus 0 then is 1. So you got to point at 1, 1. Okay, so we use that perfect power. Next one is a 3. 2 times what number minus 1 will produce a 3? 2. So this gives me 1 plus log base 3 of 3. What's log base 3 of 3? 1. 3 to the first power is 3, right? And then 1 plus 1 gives me 2, so I got to point at 2, 2. All right, what are we plugging in next for x? Very good, 5. Because 2 times 5 is 10. 10 minus 1 will give me the next perfect power of 9. So this will give me 1 plus log base 3 of 9. What is log base 3 of 9? 2. And then 1 plus 2 is a 3. So we got 5, 3. All right, now again, if you want to see the behavior near the asymptote, you got to go into the fractions there. This one's a little trickier to do in your head. Let's say I want the 2x minus 1 to produce 1/3. So to solve that, 2x would equal 4/3. Divide by 2. X would equal 2/3 it would be. So that would be another good value to plug in. That would give you 1 plus log base 3 of the 1/3 we wanted, which is 1 plus log base 3 of 1/3 is -1. So 1 plus -1 is 0. And there's your curve.